morning. I'm going to talk to you about combining Zarr, HDF5, and TIFF into a single file. Um, Given this talk in a few different contexts, so I'm not sure where everyone's coming from. So I'll just do a very brief introduction here. Zarr is a relatively new format that's particularly optimized for cloud usage and has found particular utility in um, actually recent advances in machine learning and AI. Famously, it's been being used currently for Gemini checkpointing, it's my understanding. HF5 is a kind of older format, often used for scientific data, whereas TIFF files are a much older format, I think currently controlled by Adobe, that's been traditionally used for all sorts of things, but particularly I usually think of them in the context of images. And all of these files can be used for images, but they're often used for other kind of raster-like data, anything that can be formed into an image. And so these file formats comprise several decades of work in and data, particularly n-dimensional data for really complex images or things that have multiple aspects to them, multiple dimensions to them. And there's been a lot of consternation because as these new formats have come into play, we've had to consider which ones do we use, and that creates a lot of pain for software. Some software can only read some of these, and what I want to try to address here is, are these formats really that different? Could we actually maybe combine them into a single file format? And how could this understanding advance interoperability between different pieces of software? So let me see if I can figure out how to advance the slides here. I hope that looks like my second slide. Looks like it. So why should we do this? Well, I keep coming back to this XKCD cartoon. This is number 927, and it talks about how standards proliferate. Previously there were a bunch of standards. Um, maybe you're using TIFFs, maybe you're using PNGs or something like this, or other kind of maybe even video formats. Others were using HF5, and there's a whole plethora of new formats, ASDF, for example, that also is coming up. And I think these all kind of rose because we had frustrations with previous standards, and we needed something that could fit current needs. Meanwhile, old standards also kept evolving. But I think my goal here is to try to avoid data duplication at my institute. I work for the Howard Hughes Medical Institute at the Geneva Research Campus. And there we have many applications, particularly in microscopy, where we're collecting large data sets at terabyte or petabyte scales. And quickly this is going to accumulate into exabytes. And so we're at the point where we can't afford to make multiple copies just to format our data for different pieces of software. And so my objective in kind of researching these formats and seeing how they can work together is to try to make it easier for users to read the data using their favorite APIs, meaning that they could use their favorite pieces of software to view, image, edit, or process these pieces of data. And I think this is particularly becoming even more important as we now go into this new realm of AI applications. I have to say that this is kind of not my boss's preferred way of approaching this. His preferred way would be creating an API that can read multiple font formats. And in particular, my institution, there's a predecessor to Zarr called N5, but I usually think of it as both an API that can read multiple things, as well as a file format itself. And this file format eventually got combined and merged into Zarr. And I would argue that the latest version of Zarr, Zarr version 3, is actually much more like N5 than, say, Zarr version 2. Coming from kind of other fields other than biology that my institution focuses on, there's also a different approach here from the geosciences. So there they have a format called cloud optimized GeoTIFFs. And this field has also traditionally used HDF5, or in particular a version of HDF5 called NetCDF. And it occurred to me that other people have been having a similar idea that I've had, in that they recognize some similarities between Zarr and cloud optimized GeoTIFFs. And so I'll try to address that as well. And so basically, the fundamental question that I've been trying to get to is, are these formats really fundamentally different, or can they be thought of as really the same thing, just from different kind of perspectives? So I'm going to cover mostly Zarr and HDF5 and get back to TIFF a little bit towards the end. And we'll get into the details of why are people using these new file formats and what makes them similar. So Zarr version 3, this is the latest version of the Zarr uh, file format. I think some people don't like to call it file format, but it's basically a way of laying out data. And Zarr version 3 is cloud optimized chunk-based hierarchical array storage specification. It can be used on a normal file system on your local computer or maybe your institution's network file system, but it found particularly great application for use on, say, services like Amazon S3 or Cloudflare's R2, in that it works particularly well with key value stores. In particular, the metadata that describes kind of things like the shape of the array, how it's compressed and whatnot, this is stored in a star.json file. And so that's just JSON. Whereas most of the binary data is stored in individual chunks, which are broken up into individual keys. You can think of them as files um, on here. And what makes this nice is that it's very easy to find parts of your data, which may be a high dimensional, let's say a 3D data set, and you only want a particular corner of that data in order to run your inference pipeline or your machine learning pipeline or image processing pipeline. Part of the problem that we've encountered with this is that, especially when you're trying to use this on a normal file system, the file systems quickly get overwhelmed. We end up with millions of files representing millions of small chunks that are convenient for data access, but make indexing very difficult. And so Star version 3 over Star version 2 introduced a new codec called charting indexed. And this basically allows us to take one of those chunks, we can make them bigger, and then subdivide them into smaller inner chunks. And so now this solves part of the problem in that our indexes could be smaller, our file systems are happier, and in particular, our file system admins are happier. And so this basically allows us to have individually compressed, accessible units that we can still reference within a file. We just have to go through another layer of indices in order to retrieve them. So we can still have small individual bite-sized chunk access to our data, but these are now consolidated into fewer keys, fewer files, making things easier to work with. And however, I was kind of starting to think about what we're doing here, putting chunks into files. I started thinking of some of the older systems like HDF5, and so we'll come back to that. How does these Zarr v3 shards work? Well, as I said before, right, part of the value of Zarr was that we could easily find things, but now we have to go through an additional index. And so essentially what charting did was it allowed us to put another fixed length index either at the beginning or end of a file, along with a checksum. And this is a pretty straightforward, simple index, maybe slightly bigger than it needs to be in that we're using 64-bit integers for both the offset and size of individual chunks. But it's a very simple file format in that it's very easy to look up what you need. And so at the end of the day, this just becomes one additional read request across, perhaps millions of read requests. And so that gets amortized very quickly when you're trying to work with the Zarr data set. And so the cost of this is not really too much. The other thing I want to point out about this is as phrased as a codec, that we specified this as a codec, that this can also be used recursively. That's a more advanced application, but it does allow you to create a hierarchical structure. So something I've noticed with this is comparing it with an older file format, hierarchical data file format 5. This is HDF5, which is maintained by the HDF group. This is usually thought of as a single file format. And just kind of looking at what they've specified there, this is very comparable to what's called a fixed array data block in the HDF5 world. The file format and the indexes actually look pretty similar. In some ways, the addresses are up to 64 bits. The only difference is there's this extra 32-bit filter mask, which allows you to turn on and off things like compression. And the other small difference is that there's this, they both have 4-byte checksums, except HDF5 uses something older, increasingly maybe a little bit obscure, called Jenkins Lookup 3, whereas Zarr version 3 uses something called CRC32, which is much more common. It has hardware support built into our processors these days, both Intel and ARM. And so, kind of the question that I've had is, could we actually make these things the same thing? And so there's several different ways of doing that. There's been recent research into how we make HDF5 into something simpler and or even more cloud optimized. And basically, the methodology there was to combine the HDF5 metadata into one cohesive block, and you could put that block somewhere near the beginning of the file. And so we could put the HDF5 metadata at the beginning of the file, and we could add this Zarr metadata at the end of the file, and we can even put it into the HDF5 scheme by declaring that as a data set. We just have to be very careful how we are arranging the file. But this is all possible by just making sure to pre-allocate metadata using certain HDF5 API calls. Another option is HDF5 also allows for a user block that to precede the file, and that's another place that we could potentially put a shard index. And the third option would be if we could maybe figure out how to reconcile the checksums, either adapting HDF5 to use the CRC32 checksum, or adding Jenkins Lookup 3 to Zarr as a potential checksum. We could actually reuse the same metadata structures and share that between HDF5 and Zarr. And conceptually, I think sharding, because of the way sharding was developed in Zarr, we've actually think about it backwards to how it's usually thought about in the database world. So typically, when I think about it in Zarr, I'm actually thinking about combining chunks together, whereas sharding typically describes a partitioning scheme. How would you divide the data into different files? And this is also true in the HDF5 sense, is that there is a concept of HDF5 data set, which allowed us to partition a single data set, perhaps among multiple data sets that may live in other files. And so thinking about that in that sense, I noticed that Zarr version 3 sharding and HDF5 virtual datasets were actually quite similar, in that we could actually draw one-to-one analogies between some of these concepts. And so just kind of laying out how that might work. So the Zarr uses kind of names like this for individual chunks. If we had basically 4 chunks, we call it 0 less 0, 0, 1, 1, 0, or 1, 1. But we could actually create a Zarr that HDF5 that in many ways kind of points to these same virtual data sets that are partitioning this one big data set that we actually want. And so each of these could be hybrid HDF5 Zarr shards. And we could actually just have different entry points, either Zarr.json for traditional Zarr reading, or a Zarr.HDF5 that actually just uses HDF5 virtual data sets to point to these different files. And then finally, I just wanted to come back here to TIFF. Hope I'm doing okay on time. So TIFF, again, is kind of this image file format, but instead of like chunks, they usually have thought of tiles in at least one application. More typically, TIFFs are by default usually laid out in strips of data, which actually can be quite large strips. They usually go all the way along a row, and maybe have 256 rows combined together in one contiguous block, making it easy to read strips of data. But as we kind of go for these very large imaging applications, I think we end up preferring tiles, at least, or 2D tiles, so we can have local areas of the image that have the same dimensionality of the image that we can easily process in image processing pipelines. Just also note that the geosciences community tends to use these tiles to represent n-dimensional data by just encoding different information bands within the tiles. And there's even, I think this is actually wrongly labeled, there's even extensions to TIFF that allows to describe 3D tiles in these files. So one thing, I've already told you how to combine HDF5 and Zarr, that we can separate the HDF5 metadata in the beginning and Zarr metadata at the end. TIFF metadata absolutely has to come to the beginning, but it can be consolidated, and this is what cloud optimized GeoTIFFs do. And so using one version of my previous scheme, by putting the Zarr metadata at the end, we can actually put the TIFF metadata at the beginning in the HDF5 user block. And so basically, by just adding some kilobytes of metadata, we can index gigabytes or even terabytes of image data or whatever data. Frankly, it doesn't have to be images, which could represent n-dimensional data. And we can combine them into a single file format that combines TIFF metadata, HDF5 metadata, and Zarr metadata. How I usually think about doing this, and I usually have to do this near an acquisition device, a microscope that has a camera on it, is I usually have people maybe leave a small header in the file so I don't have to rewrite the file later. So somewhere between a few kilobytes up to maybe 64 kilobytes is more than enough room for these various metadata indices. Then store the image chunks and either just add some extra space at the end or even just stop there because it's pretty easy to append to files. Meanwhile, we can create a template with our intended metadata, and then we can simply combine these two together in order to create our multi-format file. So this makes it pretty easy for people to start writing data into this, which is, for my work, one of my primary goals. Okay, and so I do have a GitHub repository that I've been slowly working on just as a proof of concept. Not really intended as a library, but I think we might get there eventually. It has a bit of a misnomer. I call it simple image file formats. And that's because I was originally working on this to try to figure out how I can consolidate different formats into a Lego-like blocks I can then assemble. So let's go through it. So first, we'll start with a HDF5 file. We use the Python library h5py. We'll basically create some data and assign it. And so we'll basically have blocks like this, where I have 4 different tiles in this image composing of these 4 different numbers. Then we can access the data using either HDF5, libtiff, or TIFF file if you prefer, or the Google TensorStore package. And you can see using these 3 separate libraries, we can actually access the exact same data. And so I think this starts to accomplish the goal that I wanted, that I can write data and make it really easy for people to access however they would like. So if you're only familiar with one of these, that's fantastic. You can still access the data. I think I'm going backwards. Okay. And so the other thing I wanted to demonstrate is that if we don't use compression, which gets a little bit messy because we might have to synchronize the indices, we can actually still read the data after editing it. And so in this case, we updated the data, we changed the different tiles, and we just changed the numbers to 1, 2, 3, 4. And now we can go through those different libraries again, reopen the file, read them, and we can see we can still load the same data. And so I think this allows us to view these different standards a bit differently. Instead of maybe competing, they can now cooperate. In this case, I've used mainly kind of the thought of addressing and editing a single file, but you can also think of doing this virtually somehow or using some kind of a virtual file system, or maybe just building APIs that allow you to present files in different ways. Okay, so I think these are just some details. I think I'm going to skip them from here, but basically, I think I talked about some nitty-gritty details about some common file formats that have started to arise, some more newer than others. Zarr3 is a newer file format, allows us to partition chunks into shards are a newer format that allows us to partition chunks into smaller inner chunks. This is particularly cloud-friendly. This is pretty similar to order concepts in HDF5, including the original data sets. And I think I've shown you how we can maybe have a single file be both the HDF5 file, a Zarr3 shard, and a TIFF file. And I've demonstrated this using Jupyter. So I hope that helps. That was a little bit deep, I think, maybe for PyData, but I hope some of you got something out of this. So thank you. Are there any questions? Let me see. Yes. So we have a question from Martin Durant. So Martin, I think, has worked considerably in Kerchunk. And this is a different approach. And I think there's another package that kind of also uses chunk-like approach that it would take many files, index them, locate all this different shards or different chunks or tiles like this, and then maybe have a additional file on the side. And in this case, uh, I think that's definitely a different approach, right? In this case, instead of actually editing the file, supplementing the data, or rearranging metadata, we just use a virtual layer like chunk or maybe virtual reality Zarr. I think those are complementary, right? Basically, I'm using the same approaches. The only thing that I'm doing different here is that I am um, actually putting them into the same file as well. And I think, as I just mentioned, another way to do this would also just be doing virtually. I think as time goes on, I think we're also finding methods that we might be able to incorporate some of Kershunk's methods of adding or supplement index into Zarr itself, or perhaps into HDF5. So I hope that answers your question, Martin. I don't know if you want to ask it directly. I'm not sure if I have. I think Patricia's still with us, that she might be able to facilitate that if you wanted to go back and forth on that. Is there any other questions? Or I don't know if Martin, if you wanted to follow up on that. So I heard a little bit of a microphone, so I'm not sure if I'm getting anyone else. I guess, yeah. I think it is a really good question, because I think and I think it depends also on kind of perspective. To what degree is one able to control your software environment? If you are a programmer and you're doing kind of the low programming using IO, then maybe using these kind of solutions might work for you. I typically work with biologists at my institution, and in this case, they often need to choose applications, not really thinking at the software library level. And so typically they don't have the option of maybe inserting chunk as a middle layer in their IO pipeline, but rather they might just want to use Fiji, and they just want it to work. And Fiji has various supports for HF5 and TIFFs, and a little bit more limited support for Zarr v3 at the moment. But the idea is that you should be able to kind of pick your application and just do it how you would normally do it, without having to maybe think about these. Whereas kind of if you're a software engineer, then I think you would want to use my boss's approach, which is use an API, use virtual reality Zarr, use Kerchunk, and adapt to multiple file formats. Whereas I think if you're the one saving one of these file formats, if you're the one acquiring data, you just want to disseminate this data as quickly as possible, then in that case, I think you maybe have the most incentive to use this kind of multi-versioning, multi-formatting approaches, in that you're really giving the choice of what to use, how to approach this to the users. So let me mark that as complete. Yeah, any other questions? Okay, well, I think that's about it, Patricia, if we want to wrap up.
Yeah. Thank you so much, Mark, for the presentation. It was amazing. So thank you all for joining us today. If you'd like to continue the discussion, you can head over to our Discord. The link is available in the reception area. And of course, a recording of the session will be available shortly for watching. For those interested in more casual conversations, the lounge is also open in the reception area where they have small groups. So see you there.
Okay,
Thanks, Mark.
yeah, thank you.
Bye.